Okay, you've probably figured out that the ABCD stuff is pretty important because it transfers to every other function after this. Okay, so let's first look at this function and put labels on them. So A, B, C, D, which letters are what? So we have an A, a C, and a D. So when I make my coordinate, I'm going to do what? So this one would be on the Y, and this one is on the X, right? Remember all that stuff? Did you go X plus 3? 2Y minus 1. Okay, so let's take some points from this original graph. So -3, 1, 0, 1, 2, -2, and 3, 0. Okay, I need you to put those coordinates through the math. So to be faster, my tip is just to go all the x's, so add 3. So 0, 3, 5, 6. And then run all the y's through after that. Okay, are we getting the same coordinates? I got a 0, 1, 3, 1, 5, -5, 6, -1. When you're done, please make sure you understand the properties of what it should look like. Did it stretch? Yeah. Did it shift right and down? Okay, make sure it looks like that. Sometimes when you have reflections, make sure you're connecting them properly and your arrows are going properly as well. Okay, working backwards is the next one. So determine an equation for g of x as a transformation of f of x. So this is the original, and we have to get to that one. Okay, tell me what your first instinct is. What do you think we did to the f function physically? Do you see anything that we did? Do you see anything that got reflected? No. Do you see any stretches or compressions? I think I did a horizontal compression, right? I squished it in. So I can see it would be by 2. So I'm going to do that. So this point is out at -2, so I'm going to move it to -1. 1, 2, 3, 4. So I'm going to take that coordinate to 2. I'm going to grab this coordinate right here, which is at a 6. Okay, so that's what it would look like if I compressed it by 2, horizontally compressed it by 2. Then I have that shape, so it's needing to go 1, 2, 3 up. Okay, so that's what I would have done to it. And remember, that would have to be in the order, so you're always looking for the multipliers first, so reflections, stretches, compressions, before you'd have to do a shift. So we have to write this, so g of x is us doing those things to the f of x. So this needs to go into the b, and this needs to go into the d. So there's your answer. A B position and a D position. Okay, inverse. So some important things with this are making sure you understand how questions could be asked. I could have asked in words the inverse. In symbols, I could have asked that. Make sure you recognize that that could be a way to ask it. Or I could say it reflects how? How do inverses reflect? Do you remember that one? Over the diagonal y equals x. That's the line that they reflect over. So those are 3 ways that I could ask the same question. So just make sure you understand what it means. So what we're doing is we're going to change x and y, right? That's an inverse. 1, 2, 3. So -3, 2 is going to have to go to the coordinate 2, -3. -1, 4 becomes 4, -1. 1, 4 becomes 4, 1. 2, 2. What's special about 2, 2? It's going to stay. It's one of those invariant points because when you switch it, it wouldn't do anything. Okay, inverse, I always find people forget how to connect them. That's the hardest part. I've had lots of people that get all the correct points, but don't draw it correctly at the end. So you have to visualize that being reflected diagonally. Do you see the visual of how that's reflected then? Okay, reciprocals. So some key ideas about reciprocals is what happens when we change the number 0 as a fraction. It would be 1 over 0, which is undefined. So where would this graph, if I reciprocate it, where would it be undefined? Here. So now I'm going to draw a asymptote. Okay, so there's an asymptote there. Now the second big idea that we always talk about is what happens to the reciprocal of 1 and -1. It stays. It's an invariant because 1 over 1 doesn't move. So where do you see heights of 1? This would all just overlap. And this 1 point would stay. So this would stay. And then the rest of the graph gets filled in. If you are moving closer to 0, you now should move away from 0. So this region is moving closer. So now I'm going to move it away. So there's my graph. Okay, sometimes there becomes an asymptote horizontally at 0. When would I do a horizontal at 0? If your original graph moves away from 0, then you would move closer to the height of 0, creating another asymptote. Okay, that's the only way. But this one didn't, so we don't. Okay, looking at this, we have an absolute value involved. And is that a right one or is that a down one, the way it's written? Down one. Okay, should I absolute and then move down, or should I move down and then absolute?
Absolute, then down.
So I'm going to do that. Right on my paper, I'm just drawing it. So absolute, this first part that's negative will change to be positive, and this will stay. So that yellow part is the absolute, and then that will now need to get shifted down. So there's the final graph, the pink one. Okay, be careful of how I write this. If I had written this, you needed to have moved down and then absolute, which would make your graph look completely different. Okay, so make sure you understand the order of that. Okay, identify the x-intercept of this graph. So an x-intercept would be where y equals 0, right? So I'm going to put a 0 into that position. So 0 equals the square root of Okay, so I'm going to do some algebra here. I'm going to square. Doesn't matter your order. You can divide by 2 or you can distribute that through, whatever. You'll get to the same spot. Sure, I'll distribute first, or you could have divided by 2. Okay, so that would be algebra some of you might have just understood that this graph just shifts left 5, and then that's it. So therefore the radical will just start there, left 5. Some of you might have just done that without the algebra. Okay, so let's graph this. So it's a radical. You better understand just the general shape of radicals, which if you have a basic radical, that's their general shape, right? So where do you start? You are going to look for any C's or D's that move your starter. So we need to start left 5. So there's my starter, left 5. And then I'm going to do an over-up chart on the radical. So what is the basic pattern to a radical? Square rooting numbers. Can you square root a few numbers from here? 1 square root is 1. 4 square root is 2. 9, 3. Now I have a 2. What letter is that 2? A, B, C, D. Which letter is that? That's a B. So what do I do with a B in a transformation sense? You always do X divided by B's, right? So I'm going to divide that over, because that's the X column. I'm going to divide it by 2. So this is a half, this is 2, this is 4.5. So I'm going to move a half over and 1 up. I'm going to move 2 over, 2 up, and then I did a 4.5 over and 3 up. Okay. Don't worry, on your exam, obviously I usually provide your little grids so that you don't have to do a freehand. State the domain and range of a radical. Okay, where is the start of this radical? Which coordinate would I start at? +8, comma +1, right? Because it goes 8 to the right and 1 up. So this is the normal shape of a radical. But there's a negative involved. Is that the A or the B as a negative? That's an A. So which way are you reflecting it? You got 2 options. Did you pick that direction to reflect? Okay. So knowing that, can you write range and domain? So the domain will go from 8 to infinity. And then the range will go from you pick negative infinity and then up to 1, right? Because it reflected, so that changed. Okay, so think about the general shape and then what happens to it. Okay, identify a function with this domain and this range. Okay, so what are we doing here? This is heading left, and being greater than this means the graph is heading up. So therefore, you're having a radical that is moving that way. Okay, so there's your radical. It's at that point and it's moving in that direction, which means there was a reflection on the which letter? B. So I need an equation. So y equals the root of -1. Okay, we always need to factor that out. And then I'm going to have to put x, what? +2. And then a +3 after. Okay, is that kind of coming together? Okay. Sketching this graph. So the first thing I'm going to do is figure out what's not permitted on the bottom of a rational equation. So I think you're going to need to factor that. Okay, there's two x values that I cannot have exist, so 4 and -1. Then this would cancel. So this one is going to be a whole, and this one is going to be a vertical asymptote. Those were the rules. If it cancels, it's a whole. If it doesn't, it's an asymptote. Okay, we're also going to talk about the degrees. What do you think? Where do you see more degrees or same degrees? The degree would be higher on the bottom, which does what? Y equals 0 would be a horizontal asymptote, would be what it would be, right? Okay, so those are your three big things. Once I cancel this and start making a table to plug it into, are you okay if I just simplify this for my brain like that? Okay, so I need this, and what is the coordinate of the whole? The whole is 4 comma what? What do you do to find that? You can plug it into this. So 4 plus 1 makes 5, so 1/5. Okay, can you put those three things on your graph right now? I need those three things on your graph. So y equals 0. Okay, those are the big ideas, right? Now the rest of it, you just do a t-chart, plug in a couple x values. So I always pick 2 x values on each side of the asymptote. So 0 and 1, -2, -3. And then you make some points. You should understand the shapes always go kind of with the asymptotes. So if you have a hole on your graph, you need to make sure you extend it so that I can see that. All right, a couple more logs and exponents. Okay, so logs and exponents, just start them all the same way. So how do we start? This is the base of 5, so give me 5 to the. I always do the same 3. 5 to the -1, 5 to the 0, and 5 to the 1. So doesn't matter if it's log or exponential, just start it like that. Because this is a log, the coordinates are going to be which order. That's where you just pick. Exponential versus log is now the order. Okay, so this is log, so it's opposite. You do output comma input, right? And then last, if there's any transformations, now you can change your coordinates. So this is a C, so I'm going to do x plus 1 . Okay, there's asymptotes involved. Do we remember how to do asymptotes with logs? This is your basic log shape. With an asymptote like that. That's a basic log. Okay, so it has a vertical asymptote. So my vertical asymptote will now be moved to 1. You have an asymptote there. So once you put your points in, if you see, how does it connect with your asymptote now? If you forget about the asymptote, my recommendation would be do a few more points. Both ways, do some extra points. If you would have done one more point here, it would have just gotten closer to this. Would have been like there. Okay? So if you forget, extend your graph more. Okay, exponential. So what does a basic exponential look like? It could look like that if it's increasing, Or that if it's decreasing. Do you remember the increasing or decreasing ones? How do I know when an exponential would grow? Why does something grow and get bigger? Your base is going to be what kind of characteristic? Bigger than 1. And it will decrease if your base is less than 1. Okay, so our base is 2. Your base is not negative 2. That could be a trick kind of question. Your base is not negative 2 because it's 2 to the x, and then it's an afterthought that it's getting multiplied with bed mass by a negative after. So like I said, I start the same way no matter what. Okay, but because this is exponential, our coordinates will go in the input-output order. Okay, so that's the only thing that changes between the two of them. And then your transformations have to happen after that. Okay, so I'm going to put an A and a D onto this. So nothing x, negative 1 y plus 2. Okay, be careful there. Negative a half, and then I add 2 after that. 1.5. Negative 1 plus 2 is 1. Negative 2 plus 2. Okay, I guess you have to visualize what's happening. What did we do? We physically did a reflection. So this is what my shape was at the start, because 2 to the x was just my original. So can you visualize that reflected and then moved up? So I have an asymptote at a height of 2. So it's very important to understand your visual of the originals, the basics, without any transformations. Okay, I see, well, Nick has a paper right in front of him. It's this yellow paper that I gave you. And I think I put on there a snapshot of just what all the originals look like, right? Maybe on the next page. To kind of have little drawings on, like, this is what that one looks like. Okay, so then on this one, it is an exponential And what's happening to it? It's decreasing. So it's B. It's a decreasing function. In order for it to have been a base of 2, I would have then had to have reflected that, right? Because this one increases. This one is the wrong reflection. It makes it reflect that way. If you had put a negative x on the top of that one, it would have worked as well. If you had done a negative b reflection on this graph, it would have been okay. Okay, last topic for the day. The last type of graph you did was the trig graphs, everybody's favorites. Okay, so again, do you understand the basics? What does a basic sine graph look like? Where does its sine start? 0. Because what's the sign of 0? 0. It's your unit circle. If you forget, go to your unit circle. The sign of 0 is 0. Then what's the sign of 90? 1. Then 0. Then negative 1. What does your cos curve look like? Where does it start? So again, if you forget, just go to your unit circle. What's the cos of 0 degrees? 1. Okay, so that's what you need to know, the basic looking curves. Sine starts midline upward and cos starts on a top, max. Okay, we're going to take a cos curve and we're going to apply the A and the B. So draw me a cos curve. This is not my final graph, this is my rough sketch. Okay, so I am going to apply the A, which is 10. What does it do?
Height?
The height. Instead of the height of 1, this height is going to be at a 10, and this height is a negative 10. Now I'm going to apply the B. What do we always do when we see a B? We always do x divided by b, right? This coordinate here originally has an x value of what? 2 pi. That's what it was. But now I'm going to divide it by pi over 2. And then let's do a flip multiply situation, which turns into the number 4. Now, to help myself out with shifting, I put tick marks on 1, 2, 3, 4 sections like that. So if this is a 4, that means dividing by 4, everything goes up by 1. Okay, now I'm going to do the final graph, which means if there's any C's or D's, now we go into that. So now I'm going to give myself some markings here. I only am going to be shifting right. I really should have done one with a D in it, but make sure you practice a graph with a D in it, because I should have probably done that. Are you going to be mad if I change something? Should I change it with a D? Can I do a +4 on the end of this? Just for, we better know how to do that. I'm sorry. Okay. If I do a +4, what I'm going to do is I'm going to kind of give myself a nice little dash line, because it's not on the graph. I'm just going to kind of say, here's a guideline for myself. It's not an asymptote. It actually should be erased after, but okay, so 4 is the middle. What's the new top height? 14. I'm going to mark that up there. What is the bottom of this graph going to be at now? -6. Okay, I'm going to grab one point, which is 0, 10. Where should it go on the new graph? Where should I start this all out? I have to move it right 2 and up 4. Right 2 becomes 2, 14. So there's the coordinate. And then we're going to finish the pattern. So that was at 2. So at 3, I should be hitting the middle. At 4, I should be hitting the bottom. At 5, the middle. At 6, I should hit the top. And you have to go exactly from 0 to 6. So can you also work to 1? You should be at the middle. And then at the bottom. Okay? If I don't have intervals, you need arrows, right? But if there's intervals, you have to go exactly. Okay, last question was making an equation. So you have a max at 5, 300. And then a min. So that's what happened on your graph. You had a max and then a min. Okay? If I asked you this on your exam, would you be able to get me any of those coordinates on the picture? Could you find me this coordinate, this one, this one? Could you find those coordinates? Okay, that's a hint. There might be something like that. I might ask you to find a random coordinate over here. over there in the middle, whatever. Can you do that? Okay. So let's do this first. What height would those middle points hit?
200.
200. So this is the format you're going to have to follow. We're supposed to do a sine and a cosine curve. We have to do a sine and a cosine curve. But this is the format that you follow, right? Where do you put the 200? Which letter does it go to? The D. It's the shift up. And it doesn't matter, they both are 200. You'd have to shift up 200. Next, I'm going to talk about the word amplitude, is how much did I stretch above and below. So from 200, the higher point is how much above it? 100. There's 100 of space. So that is which letter? A is the stretch, the vertical stretch, right? Okay, let's talk about the period of the cycle. So normally it takes you 2 pi to go through a cycle. Okay, how much space has passed from there to there? 10. Is that a full cycle of this? No. How much is a full cycle?
20.
So 20 equals the original 2 pi divided by something, right? 2 pi over b equals period. Right? Because our normal is 2 pi, and we could potentially compress it by a b value. So pi over 10, because I just reduced it, 2 pi over 20. Okay, and the last step is the only thing that's different. The starter point. So let's do cos first. I'm looking for a cosine start, which means I would need a location on the, where? I need some kind of point on the top. Cosine starts on a top. So I could use this coordinate, which means it's a shift 5 to the right. And sine. Do you remember how sine starts? I need a middle, but heading upward. So if you try to take this one, it's inaccurate. Why is it not good? Even though it's a middle, you're heading down through it. So you either have to figure out this one or this one would both work. And you could pick either one. Can you figure out whichever one you're picking? Would you know how to get the x value there? So for instance, what is the x value of the one in between? 10. So if this is 5, 10, 15, this one would be at 20, and this one would be at 0. So you can see there's my cycle, my full period is 20, right? So you could just write x with no c in there, or you could have put x minus 20. You could put x minus 40. You could put x minus 60, right? There's endless answers, really. Okay. Graphing. That was a lot of, you've done a lot of graphing this year. So tomorrow and Friday, you're going to work on everything graphing, right? Does that work?